So let me just say welcome. And my name's Marc-André, which I should have spelled out there. I'm a research scientist at the EPFL Space Center. And this workshop has been co-organized with Skoltech. And it's from our point of view, it's from this perspective of sustainable space logistics, which is a connecting theme for a variety of topics, like the ones we see today, around debris, proximity operations, on-orbit servicing, and many others. And here we've got a strange view of the program, which hopefully you've all received. So here we are, starting at 4 o'clock Moscow time. And we've got hopefully Jean-Paul and Anton, who will say a few words. I'm not sure if they're connected yet. And we have our first session, which is essentially around space debris, and then some talks linked to on-orbit servicing. This will last a little over an hour, after which there's a coffee break for about half an hour. And then we get into the second major part, which is space logistics more generally. I want to point your attention to, there's a keynote shortly after the break by Professor Koki Ho, who we're very pleased to have, who's really a specialist of space logistics modeling. And then a variety of more talks, and we conclude in about 4 hours with some concluding remarks. For Q&A, we're going to ask you to please type your questions in the chat, or even better, there's a special chat called Q&A, and we will read them off. We'll probably take a couple questions after each talk, and then keep the rest for the dedicated discussion and margin time at the end of the sessions. I think those are the major points. You're also free to raise your hand in the discussion margin, and perhaps we can have people speak depending on our speed and the dynamic. So I want to welcome you all to this workshop on on-orbit servicing, debris, and proximity operations, and the sustainable space logistics. And the EPFL and Skoltech, we're very proud to have you all. And we want to wish you a warm welcome.
So I'm the director of the EPFL Space Center, and otherwise I'm also a professor in astrophysics for those who don't know me. And I just have a 3 slides to motivate a bit why we're interested in sustainable space logistics at EPFL. As you know, and I like this sentence, Houston, we have a problem. We've been doing, space science and space observation and, space activities for, more than 50 years now, 60 years even. And the landscape has changed completely with, launch costs that are decreased, miniaturization, a lot of activities that our humanity are using for living that depend on space, Earth observation, navigation, communications, exploring the universe, which is at my heart of my studies. And there's saturation of low Earth orbit and geostationary orbits. There's this problem of space debris. And then there's coming of this mega constellation, which potentially is an issue, and we don't really have also an effective space law that can rules all that. And so if we continue like that, we really get into some problems eventually. And I think that's something we should address and try to develop more research in this direction. And I guess the motivation came here at EPFL because we launched SwissCube in 2009, and we realized quickly after that, it was at the wrong orbit, and it possibly could be, a danger to the infrastructure in space. And so we developed this sustainable future and with this idea of cleaning space, and that was the Clean Space 1 project. And now this project, is more mature because it's been awarded a big check from ESA to go and collect one of ESA space debris. Right, so in 2019, we were fortunate to have some funding from our space agency in Switzerland to develop activities around sustainable space logistics. And this picture is just give you a flavor of the various activities that could be linked to space logistics. And of course, this ESA Adrios mission is a big player in our motivation. But of course, cleaning is one thing, but also designing a future and future missions that are sustainable by themselves is probably also the best move, because if eventually in the future there's no things to clean anymore, then it's probably also much better for space. So I just just wanted this say a few words like that. I don't know if Anton is around and if he wants to add something here.
Hello everyone. Unfortunately, I didn't prepare a presentation like Jean-Paul did. It's very nice to see everyone again. I see a lot of familiar faces and basically saying hi to all of my Swiss friends. For us, this topic also came into, let's say, existence when we started to work with various projects in Roscosmos. And I can see that there is also substantial interest in sustainable space. So in my discussion with various people, I can hear topics like space debris. Obviously, there are topics that are connected to infrastructure in space. Some of you may know, especially our Russian friends, may know that there is a very ambitious project that's called Sphere, which targets deployment of a lot of satellites, not a mega constellation in the sense of Elon Musk, not 11,000, but approximately 600 satellites for telecommunications, for remote sensing, for improved navigation, and even though we're putting, well, compared to, again, mega constellations, it's a relatively small number of satellites. But for example, in people with ballistics in Russia, they understand this problem very well. And the question of possible collisions in space is on the top of the agenda. So it's important to understand this. At the same time, we see that there is a dream. Humanity has a dream to go to Mars. As I was telling some of my students, I think just in the last maybe 2-3 years, we can see that this dream may just as well become a reality. To tell you the truth, I've been studying Mars for the last 20-something years. And sending a person to Mars was a very distant thing, something that we will do in a very far future. And now I think that it's actually becoming a reality, and at least just looking at the amount of money that will be involved in this enterprise is actually attainable. We did some estimates with Anne-Marlène, as you know. We estimated that mass for an expedition that will need to be delivered will be approximately 100 tons. 100 tons to Mars will cost approximately $100 billion. And this amount of money is not something that doesn't exist in the world. If you look at capitalizations of large companies like Apple, or what kind of budget is spent by Elon Musk on his space enterprise, this is all becoming reality. And you know that Russia invests into plans to develop super heavy launch vehicles. China is investing into this. So this may be a new space race just as well. There are very ambitious plan to explore the moon, and the first launch of SLS is going to happen just later this year. And whenever we listen to the United States talking about the moon, they say, oh, the moon is just the stepping stone to go to Mars. So all of these issues, I think, bring us to sustainable space development, because as we know, for example, the American lunar program was developed and implemented really, really well, but then it just stopped and all of the technology were lost. there were a lot of leftovers that became space shuttles that becomes International Space Station, but the program itself was not sustainable. So I think the question that we are targeting now, and actually that was an outcome of the workshop that Jean-Paul and a little bit of myself organized in, I believe it was 2018, Space Vision 2061. And we discussed a lot of these topics, and sustainable space program is a big issue. There are a lot of different angles. I mean, space debris is one, sustainable exploration by humanity is yet another. So I think all of these issues we will discuss in this workshop, and I'm very happy that we have accumulated so many people and we have such a big representation. So I wish you very good work. I will be listening very, very intently because some of the projects that we will be presenting, these are the actual projects we are implementing through various funding schemes. So good luck and good work. Thank you very much.